Hi everyone, I'm Sudhir. I'm going to talk about word embeddings, a topic in text analytics. So, what is text analytics? So, it is a process of extracting information from text which is present in various forms of documents, such as images, Word, PDFs. So, to extract this kind of information from text, we try to create a lot of models or patterns. So, why text analytics is so important these days? So, data is generating at a rapid speed and the generated data is not in a proper structure. So corporate and business need to analyze textual data to understand customer activities, their opinion and feedbacks to successfully derive their business. And to study the unstructured data, text analytics is so important. And to compete with the big textual data, text analytics is evolving at a faster rate than ever before. So before talking about word embeddings, I would like to talk about different kinds of representations of text. So a machine cannot understand a raw text. We cannot feed directly a raw text as an input to the machine because it can only understand a binary form, that is zeros and one. So these are different kinds of representations. One hot encoding, bag of words, co-occurrence matrix, and n-gram models. So one hot encoding converts text into vector forms. So in this method, each word in dataset is represented by a vector which contains zeros and one. The vector length is usually taken by the size of dataset, that is the number of words present in our corpus or in our vocabulary. So here are 5 words as an example. So one hot encoding generates a diagonal matrix with one as its entry in its own area and the rest of all are zero. So now the word white is represented by a vector. So here we can see that 10000 represents word white and similarly the other words. And bag of words, one of the other technique to convert words into vector. So is a method to extract features from text documents. These features can be used for training machine learning algorithms. It creates a vocabulary of all the unique words occurring in all the documents in the training set. So difference between one hot encoding and bag of words is that in bag of words we try to uh, create vocabulary of the unique words. So here is an example of consider three statements d1, d2, d3. So we create a list of unique words over here. You can see that unique list of words. I am feeling very happy today, not well, wish, could go to play. All these are unique words generated from the above three statements. Now, for each word, the frequency of the word in the corresponding document is inserted. As you can see, the matrix generated in here is that I in D1, I is appeared only once, whereas in D3, I appeared to be twice. So that's where 2 is appeared in the matrix. Similarly, that's how all the matrix is built. So the above table depicts the training features containing term frequencies of each word in each document. This is called bag of words approach since the number of occurrence is important but not the sequence or order of words matter in this approach. Similarly, we have one more technique called co-occurrence matrix. So in this method, we consider context of the sentence and co-occurrence values of words are calculated. As example, consider I love programming, math, tolerate biology. So, and consider one more statement, I love food. So, I is co-occurred with the word love twice in both the sentences. So that's how for I and love, the entry is 2. And similarly, all the values, other values are calculated. If you can observe here, programming and math share the same co-occurrence values. As you can see here, programming and math have the same co-occurrence values. So that means that they can be placed in a similar area, meaning that in this context, they both mean to be the same. This technique gives a relationship between the words, but it is too expensive since we are talking about a very high dimensional space. Therefore, we need a technique that reduces dimensionality for us with the least data loss possible. So that's where word embeddings come into picture. What we have talked earlier about all these techniques are font-based models. means they do not preserve any relationship among the words. Word to vector is a popular method to generate word embeddings. So what word embeddings does is it preserves relationship between the words. This converts word to vector converts words into vectors, and with vectors we can have multiple operations such as add, subtract, and calculating the distance between those two vectors and find how similar both they are. And this is how relationship among words is preserved. So as an example, king, man, woman. So vector of the word king is calculated and we subtract that with the man and we add to the woman and then we finally get the vector for the queen. So this is how we can play around with the vectors. So but now the question is, how are these relationships are formed between these words? So in simple terms, word to vec causes the words that occur in similar contexts to have similar embeddings. For example, consider the below statements. The kid said he would grow up to be a Superman. The child said he would grow up to be a Superman. Kid and child will have similar word vectors due to similar context. But how does word2vec generate vectors from words? We So there are two algorithms basically. One is continuous bag of words and another is skipgram. So in continuous bag of words, we predict the target word from the context. As you can see here, the statement taken here is the quick brown fox dash over the lazy dog. So all we are trying to do is that we are trying to predict the word which would fit properly in that statement. And skipgram, the another technique, is just the other way. We try to predict the context words from the target. So if we give the target as an input to the neural network, it tries to predict the context words. So how SIBO continuous bag of words work? As an example, I've taken one statement: hope can set you free. So in this continuous bag of words, primarily we have to calculate one hot vectors for each individual words, and then we have to set a box size. Here box size is taken as 3. So hope can set is in these are the 3 words present in the box. So now we are trying to predict the middle word from the surrounding words from hope and set in continuous bag of words. So the both hope and set are passed as inputs to the neural network, and we are trying to predict the word can. So there is a hidden layer. There is a hidden layer in the here of the size 3 as the box size. So it predicts the weights. So once these inputs are passed to the neural network, it predicts the output, which might not be the same as the word we are expecting. So actual target is can, but it might be giving some other vector. So we try to calculate the difference between the weights and we try to minimize the error all the time. So that's how we compute for the remaining words in the statement 2. And similarly for the skipgram, we try to give input the predicted word, the target word to the neural network, and we try to predict the context words from here. And similarly here also we try to compute the weight matrix and try to minimize the error between the actual and the predicted word. So after those two techniques are done, how do we get the word embeddings for each word in our statement? So once the weight matrix is computed from any of those two techniques, and once we have the word one hot vectors of each individual word, so we try to multiply both of them and we will get a vector which is nothing but the word embedding. So here the weight matrix is of size 3 by 5, whereas the one hot vectors is of size 5 by 1 each. So when each one hot vector is multiplied with the weight, that is when 3 by 5 matrix is multiplied with 5 by 1, the resulting matrix is 3 by 1. So which means that we have reduced the dimension of vector from 5 by 1 to 3 by 1, which is what our word embedding does, which we are trying to do from all the time. We are trying to reduce the dimension. We are trying to reduce the dimensionality, and in similar way we are considering the relationship among the words. So this is how word embeddings do. So we can try to improve the accuracy of the word embeddings by choice of our model architecture. We can use continuous bag of words or skipgram. Usually for the larger data set we will be using skipgram, and for the small data sets we can use a continuous bag of words. We can improve the accuracy by increasing the training data set, increasing the vector dimensions, and we can also increase the window size. Earlier in this slide we have taken 3 as the window size, but we can increase the accuracy by increasing the window size too. So what are the applications of word embeddings? So few areas where word embeddings is widely implemented are analyzing survey responses, analyzing comments, or music or video recommendation systems. So basically, we can analyze the comments in Twitter or FB through the word embeddings. Each word in the Twitter is taken as a word embeddings, and we'll feed it to the neural network and we'll try to predict. So that's how in a lot of areas word embeddings is implemented. Thank you for your time.